Welcome to Module 1, Lesson 4. So today's lesson is going to be focusing on understanding the meaning of an unknown as the size of the group in a division. So kind of going off of previous lessons that we've talked about how in multiplication, so like 3 times 4 equals 12, the 3 represents how many groups, the 4 represents how many are in each, and the 12 represents the total. So now we're going to be kind of talking about the same idea, but in division. So we can kind of basically do pretty much the same steps to understand this, but since it's division, it's kind of backwards. And that's always kind of a good way to remember multiplication and division's differences, is that division is basically multiplication, but backwards. So if you know that 3 times 4 equals 12, you'll know that 12 divided by 4 equals 3. But kind of talking about that is that in division, there's a different form on how things go. Because in multiplication, you're trying to find the end goal. You're trying to find what is the total after I have all these groups, how much do I have all together? So the difference with division is that you're starting with that total. You have that total and you're taking that total and you're breaking it apart into something. As an example of that, if I had, let's say, 12 divided by 4 equals 3, and we'll talk about the reason why it equals 3 here in a little bit. The 12 in the division sentence, the very first one, the very first factor will always represent the total. How many are there in total? For an example of this is that I have, let's say, 12 Skittles, or 12 M&Ms, or 12 Milky Ways. Basically, choose your favorite candy. I'm going to stick with Skittles for me. And I'm going to say the 4 right here is how many kids I have, or how many scholars I'm going to be giving these Skittles to. So I have a total of 12 Skittles. This 4 is going to represent how many groups I have. And once again, that word can be interchangeable with like scholars, desks, trees, gardens, rooms. It's interchangeable, just being able to recognize that it's talking about a group. And then this 3 right here will represent how many are in each group. Just kind of like what we're talking about here, the meaning of the unknown as the size of the group. We're talking about how big is each group. Now, I can draw a picture to this. Yesterday, we started with how many rows, how many columns, or how many rows, how many are in each row, and then we put them all together. This time, it's a little different. We'll kind of start with, just to stick with those Skittles. Let's say I have those 12 Skittles, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I have 12 Skittles up here. Now, if the 4 represents how many groups I have, I need to make 4 groups. Now, I can't really just circle and make things around these, because if I don't know how many are in each group, which is what we're getting to, and just have a normal problem that looked like that, you don't know the answer is 3. So you can't just circle 3 like that. So what you can do is that I know I have 4 groups, and so I'm going to make 4 little baskets here. Now, I'm going to kind of do repeated addition, but a little bit backwards here. And what I'm going to do is I'm going to take each one of these Skittles, and I'm going to put them one at a time into each one of these baskets. And as I move them, I'm going to erase them up here. I'm actually going to put them down here. So with that, I'm going to go ahead and do that, but pay attention. I'm going to do 1 at a time for each one of these slots. I'm not going to put 2 at a time, or 3, or 2 here, and then 1 here, and then 3 here. It'll be 1 at a time for each and every single one of them. So I'm going to move this one right here. I'm going to put it right there. So now there's 1 in that slot. I'm going to take this one and put it here, and you're just going to keep repeating this. Now, since you've gotten to the end of it, now you come back to the beginning and you do 1 again, and you just keep doing that until you run out. So I'm going to erase that one, put this one here, put that one there, this one here, and now I'm at the end. I come back to the beginning again, put this one over here, put this one down here, so on and so forth. Now I'm completely out of extra Skittles. I have nothing left. There's no remainders here. And I have filled up all my groups. Now it's a good thing to double check on this, just to make sure you did your math right. But just like with multiplication, these groups have to have the same amount in them. And this has 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And you can double check and make sure that there's still 12 Skittles. You can go 3, 6, 9, 12. So I still have 12 and I have 4 groups, which means if I have a total of 12 Skittles put into 4 groups, how many are in each group? And you can just, at that point, look at one singular group by itself and count out how many are in there. And you can see there's 1, 2, 3. There's 3 there. So that way, I know that 12 divided by 4 equals 3. But more specifically, that I have a total of 12 divided by 4 groups, or split into 4 different groups, that there will be 3 in each one of those groups. Now, I'm going to do this again. I'm going to do a different problem that doesn't have the answer already here. So you already don't, so you can't kind of be like, oh, I already know there's going to be 3 in each. I want to show you an example where you can use this to actually find the answer you're looking for. So let's do, I have a total of 20. I'll do a little bit of a bigger one, just kind of show that this works in multiple areas as well. So once again, the first one in the division sentence equals the total. This is very important. It's going to help a lot in the future, I promise that. So in division, always starts with a total. And I'm going to divide that by, let's say, 10. Once again, just do a little bit bigger as an example here. And this is going to represent how many groups I have. I have 10 groups. And then I'm trying to find out, I'm trying to solve how many are in each one of these groups. If I have a total of 20, I have 10 groups, how many are in each group? And let's say, let's use like tomato plants as an example for this one. I have a total of 20 tomatoes. And I have 10 tomato plants, and they all have the exact same amount of tomatoes on them. How many tomatoes are on each plant? So that's how this question is being worded here. And so, once again, I could have those 20 tomatoes written out here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. A lot of circles there. And there are 10 groups. So I'll make 10 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll put one last one over here so it can fit a little easier. Same thing we're going to do here. We're going to take one tomato and put it into each plant. They're boxes, but we can represent them as those 10 groups or those 10 plants. So once again, I grab my eraser, and as I put one in, I'll erase it up here saying I've used it now. So I'm going to take this one, put it here, and just go down the line as such. And make sure, you want to make sure that as you're putting them in, you are making sure you're counting it, or else you'll accidentally get a number that doesn't work because you either counted one extra, or you'll have an extra because you didn't count it. So it's very important to make sure you counted them properly. I'm just gonna make sure I did that myself, because as I'm talking, I think I may have just accidentally erased one. And 1, 2, 3, 4, 5, 6, 9. Yeah, I think I erased one extra one right there. So I double checked my work. That's a very important thing to be doing, because sometimes you can think that you've done everything perfectly, and in your head you could have, but as you're writing it down, you may have made a mistake. Like you might have been like, oh, the answer is 6, and you accidentally rolled a 5 for some reason. Sounds weird, but it does happen. I just accidentally erased an extra one as I was going because I was getting in that motion. I just double checked my work. I'm good. And then once you've gotten to the end, once again, you come all the way back to the beginning and you repeat it again. So put one here, erase it there, put that one there, put that one there, put that one there, put that one there. We kind of do them mildly at the same times. You gotta be careful so I don't break this board. And there we go. Now there's none left. And now I have 10 groups. And the important thing to realize is that every single group has the same amount in each. Now we can answer the question. I have a total of 20 tomatoes, and I have 10 tomato plants with the same amount of tomatoes on each. How many are on each plant? And you can just go 1, 2. There's 2 in each one of those groups. So your final answer for this question would be 2. Now, I've been kind of doing the circles. I've been kind of drawing them out like this, but you can represent this in different ways as well. And you may see this on Zern, or you may see this on one of your homework assignments and problem sets, where it might give you just two big circles with shapes or pictures in it. Like I'll say there's 3 flowers in here. There's also 3 flowers over here. And the question will ask, you have 6 flowers split into 2 groups. How many flowers are in each group? And then you would write there are, and once again, you're only looking for how many are in one group, because if I have a total and I'm splitting them into groups, you're trying to find out how many are in each group. So I'm going to look at just one and be like, out of these 6, but when they're split into 2 groups, there's a total of, or I'm going to be careful here. I'm not going to use the word total there, because in the division sentence, this starts with a total. So I'm going to be careful on that. So if I have a total of 6, 1, 2, 3, 4, 5, 6 flowers, and I'm taking that total and I'm splitting it into 2 equal groups, how many flowers are in each group? And then you can just count out one group and go 1, 2, 3. And your answer would be, there are 3 flowers in each group. Now, recognizing that is important because it's going to help with multiplication, it will help with division, and it's going to help with a lot of other things down the road as well. Because I can look at this picture and be that can be either 2 times 3 equals 6, or it can be 6 divided by 2 equals 3. It's just making sure you're able to recognize it, because it flows back and forth. Because if you can recognize this as a multiplication, it'll help you understand it as division, and if you can understand it as division, it will help in multiplication. So I hope this lesson was helpful, and I'll see you guys in the next one. Have a good day.